Hey everyone, in this video we're going to go through the key points that are going to be assessed on your circular functions test. So you can see there the key skills and knowledge that you need to know, but if I just go to the rubric, so you should have a copy of this as well, you can see them elaborated a little bit in a bit more detail. So this is what will appear on your test, or the skills that you will be assessed on. Okay, so in this video I'm going to go through these slides, and as I go through them I strongly encourage you to be writing down the notes as I speak and pausing as you need to, and printing any diagrams or drawing the diagrams, doing whatever you need to do to learn the content. So this is a summary of what we've already done, but it's extremely important that you still listen because as I said, these key skills are going to be covered in your assessment. Okay, so first of all, the unit circle. So hopefully you understand the key features of the unit circle. So what we have our angles. Let me just highlight maybe in a different color. Let's do, I'll stick with what I had. We have our angles in degrees, okay, and that goes right around the circle. And then we've also got the equivalent in radians. So you can see 0 degrees is equal to 0 radians, 30 degrees is equal to pi on 6 radians, 45 is equal to pi on 4 radians, and so on. Okay, so you need to understand those angles both in degrees and radians, so going all the way around. We're going to fill in a blank one in a second, but before we do, you will notice we've got coordinate points around the circle. So these come from the triangle that is drawn. So if I draw a triangle in here, and you'll hopefully remember doing your triangles, and this is 30 degrees. All right, so if I just take out that triangle, 30 degrees, or it's pi on 6 radians, we have this side is our hypotenuse, this is our opposite side, and this is our adjacent. Now, if we're working out sine theta, so remember our hypotenuse is always 1. Okay, so we've got a, it's a unit circle, so our radius is 1. Okay, so that's how we get the hypotenuse of 1. And then if we're working out the opposite side, so we use our sine ratio, so sine theta equals opposite over hypotenuse, so our angle is 30 degrees. Opposite, we don't know what it is, and hypotenuse is 1. So the opposite side, and I might just write op so we don't think it's 0, is equal to sine 30. And if I was to do sine 30 on my calculator, which is going to be a bit time consuming, it's going to be 1/2. Okay, now you'll notice that that value has been given to you here. Okay, so when we're reading these points around the unit circle, they're actually coordinates on a Cartesian plane. So if you can see here, we've basically got a Cartesian plane. All right, so we've got our X and our Y, and all these are just coordinates. So what I've highlighted there is our Y coordinate, and that represents our sine. Okay, then on the other side, I might do this in blue. If we were to find the adjacent side, we're going to be doing cos theta equals adjacent over hypotenuse, which is 1. So your adjacent side is equal to cos 30, which is √3 on 2. So your coordinates x, y, as we go around the unit circle, the x gives you your cos value and the y gives you your sine value. So let's say I wanted to know what sine of 150 degrees is. So there's 150. All right, so this is our reference angle, which is 30. We're going to do that a little bit later. But I know that I'm reading the sine value is the y. All right, and you'll notice it's the same there, 1/2. If I went around and did 210, my reference angle is still 30. And there it is, negative a half. And remember, your quadrants are either positive or negative, and sign in the third quadrant is negative. That's why it's negative a half. And then if we go around in the fourth quadrant, we get negative a half again. So we get half for each of them, and then the sign positive or negative just depends on which quadrant we are in. Okay, so we use that theory to help us fill in the unit circle, which we're going to do on the next page. I'm just thinking if there's anything we need to know. I think it's a bit easier to do when we're filling it in. Okay, so I might keep returning to that previous one where I've drawn all over that unit circle. I might have to clear it. All right, so with your unit circle, all right, so here's the same unit circle that's got all the values have just been taken off. Okay, so we always, I'm going to be consistent with the previous one. We're going to put our degrees here. So there's 0 degrees and 0 radians. And the radian sign is like a little C, but we don't tend to write that. We can just leave it as 0. Now, as we go around our unit circle, all right, so we're going to do our reference angles, 30, 45, and 60. So there are our three main ones, just going to be repeated, and then we've got 90 here. All right, so as I go around, all right, I might just leave these 3 in the middle of the second quadrant for a sec. So this is going to be 180 degrees. So if you've just done one half of the circle, it's 180 degrees. If I'm doing 3/4 of a circle, we're going to be at 270 degrees, and then I'm back at 360. So I might just put that underneath because that might help us later on. Okay, so with our angles, and we're going to be repeating this a lot in this video. So there's 30 degrees. So this angle here is going to be 180 minus 30, which is 150. Then the next angle is going to be 180 minus 45, which is 135. And then we've got 180 minus 60, which is 120. So the angle, so this is going to be, this is 30, and this is 30. And this is 45. This is 45. And then, let me just do in green. This is 60. And this is 60. So remember, we always go from the horizontal. All right. Now, if I just want to get rid of that because I don't want it to be too messy with me writing all over it. Now, you're probably thinking, well, why wouldn't I just have this? Okay, in your assessment, you're not going to have the unit circle. So you need to be able to fill in the blanks, basically. So you'll have some information will be given to you, but you need to fill in the unknown parts, okay, the stuff that's been blanked out. All right, so when we're going in this direction, we're going to be adding 30. So 180 plus 30 is 210. Then plus 45. It's going to, so 180 plus 45 is 225. And 180 plus 60 is 240. And then we can just keep going. So remember, we always go from the horizontal. So this way I'm going to do 360 minus 30. 360 minus 45. Whoops, 315. And then 360 minus 60 is your 300. All right, so they're the angles you need to remember in degrees. Okay, we're going to do radians in a second. All right, so you need to fill them all in. So you'll see there that they're there. Okay, but you need to remember how to put them in. All right, so with your radians, okay, later on in the PowerPoint, we are going to do the conversion. All right, so we're going from degrees to radians, so we're going to be multiplying by pi on 180. All right, so we're going from degrees to radians. All right, so 30 degrees. So I might just going to write it here. So times, okay, silly me, can't remember, what was it? Pi on 180. Pi on 180. All right, so basically to do the conversion, we're going to do 30 times pi on 180 So 30 on 180, we can cross those zeros out. So 3 on 18, so that simplifies to pi on 6. All right, and then you can go around and continue. So then we've got pi on 4, pi on 3. When we're at 90 degrees, that's pi on 2, okay, because 180 is the same as pi. So if we're 90 degrees is halfway, then in radians, it's just dividing pi by 2, because 180 divided by 2 is 90, pi divided by 2 is pi on 2. All right, and then we continue around. So for 120 degrees, we can go 120 times pi on 180. So just simplifying 12 on 18. So what's that? 2 pi on 3. And then you keep going around. I think it's going to take me forever if I keep filling them in. So you can use this conversion to help you. If you were going from radians into degrees, so let's just say we didn't know what 270 was, but we were given the radian measure, which is 3 pi on 2. All right, so we would do divided by 180 on pi. Not divided by, times. So we're going to do 3 pi on 2 times 180 on pi. And your degrees are, majority of the time, if not 100% of the time, not going to contain pi. So we're just going to get those pi's cancel each other out. Then we're left with 3 times 180 over 2. I can just simplify that by doing 180 divided by 2 is 90. So 3 times 90 gives us 270 degrees. All right, so you can use that conversion if you needed to put in the degrees if you were given the radians. All right, now going around for our exact values. So when you're doing a trig in methods in year 11 and year 12, you do need to know your exact values off by heart, but you can learn the triangle, so we're going to do that later. I don't tend to say remember the unit circle, or you can remember the table, but if you've got the units, if you prefer the unit circle, there is an easier way of is quite an easy way of doing it. Now, just as our starting point, so remember this is your cos and this is sine. And we can think of the graph of cos and the graph of sine, knowing that cos starts at 1 and sine starts at 0. Or we could also say, well, this is our x-axis. It has a radius of 1. So at this point here, x is 1, we're on the axis, so y is 0, okay, and then you can fill in the same here. So at this point here, y is 1, x is 0, all right, we've got a y-intercept of 1, and when you've got your y-intercept, x is 0. On the other side, we're going to be at x is -1, 0, and then just down the bottom here, we're at y equals -1, x equals 0. All right, and it all relates to the graph as well. So if you prefer to think of it in terms of the graph, you can. All right, now going on and filling in these empty spots. Now, let's just go back to the one where we've got it filled in. I might just rub this out so we can see it a little bit better. Now, you will notice that they are repeating because the unit circle is symmetrical. And that's why we just need to always remember our reference angles 30, 45, and 60, and the exact values that relate to them. All right, and then we can work out anything else if we know those angles. Now you'll notice with your coordinates, they all have a denominator of 2. So if I'm filling in this unit circle, I can just say, all right, that's going to have a denominator of 2, that's going to have a denominator of 2. And going back, you can see if we're just looking at the x coordinate, it goes root 3, root 2, root 1, and the square root of 1 is just 1. So we're going to have root 3, 2, and you can do the square root of 1, but the square root of 1 is just 1. And because 30 and 60 are complementary angles, the y is just the opposite. So then when I'm going back, it's just going to be root 3, root 2, and then 1. You'll notice with 45 degrees that they're the same, and that's because if I just quickly draw the triangle, if I had 45 degrees here, here is 90, and this is also 45 degrees, I have an isosceles triangle. Not an isosceles, a scalene triangle. Or is it an isosceles? I always get them mixed up. A triangle that has two sides that are the same. All right. So that's the good thing about 45 degrees is cos and sine are equal to each other. Now for your others, we can see they're just the complement of each other because 30 and 60 degrees add to 90 degrees, so they're complementary. All right, when we go around the unit circle, these angles here just repeat themselves. That's what our reference angles are. So if I go back to this unit circle, you will see that here I've got the same, it's a bit hard to see with the purple, but you can see I've got root 3 on 2.5. The only difference is that the x-coordinate is negative, and that's because we're in the second quadrant, and in the second quadrant, cos is negative. So let's do that again. So root 3 over 2, half, root 2 on 2, root 2 on 2, and then half, root 3 on 2. Now, the x is negative. We're in the quadrant where x is negative, and cos is also negative. So remember, as we go around our unit circle, so just going on to the next slide, cos is negative in that second quadrant, and sine is positive. So we've got negative, negative, and negative. And then that's just repeated all the way around. So if we have a look here at the completed one, and remember we always go from the horizontal. So we've got the same, let me just highlight it in a lighter colour, maybe in yellow. All right, so see how these are all the same? And they're actually the same colour, which is good. And you did this on your plate, all right, because these angles are all 30 degrees. It's just whether, it just depends on which quadrant you're in as to whether your x-coordinate or your y-coordinate is positive or negative. Okay, so you should be able to, if you can fill in this part here, you can do the remainder of the unit circle. All right, but these angles here, or these exact values I should say, are the key to your unit circle. If you can recall them, you can work out any other value on your unit circle. All right, so just make sure you can complete that unit circle. So understanding, I suppose, how to convert from degrees to radians and from radians to degrees. The degrees are obviously easier, okay, because sometimes working with fractions, it's a little bit hard to tell what goes where. But just do your conversion if you need to. I'm just trying to think if there's anything else we need to do there. Okay, let's move on to the next one. So the 4 quadrants in your unit circle, and this all relates to the graph of your sine, cosine, and tangent functions. So in your first quadrant, remember, they're all positive. So we use A for all. In the second quadrant, only sine is positive. All right, so S for sine. In the third quadrant, only cos, oops, not cos. I was looking at the wrong thing. Only tan is positive. And then in the fourth quadrant, cos is positive. So you could say all stations to Caulfield, ASTC. You could also think of the graphs, and we'll look at the graphs shortly. If you're doing a sine graph, it goes like this. And if we were to split it into their 4 quadrants, so this is quadrant 1, quadrant 2, quadrant 3, quadrant 4, you'll notice that quadrant 1 and 2 are above your axes, so they're positive, and 3 and 4 are below your axes, that's why they're negative. For your cosine graph, it looks something like this. So there's quadrant 1, quadrant 2, quadrant 3, and there's quadrant 4. So you can see quadrant 1 and 4 above the x-axis, so positive. So that's why we're C is positive in the fourth quadrant. And then for quadrants 2 and 3, it's below the axes. So that's why why cos is negative in the second and the third quadrant. Now, as for tan, we don't have to really think about the graph of that, but tan is equal to sine over cos. So if we think about this third quadrant for tan, so we've got negative sine over negative cos just in this quadrant here. When you're dividing a negative by a negative, it gives you a positive. All right, that's how we end up with a positive in the third quadrant. But just remember, all stations to Caulfield. Okay, moving on. So symmetry properties of the unit circle. So remember with your plate, we always go from the horizontal. So if you can't recall that, you're going to make errors. So your angles always go from the horizontal. So for the diagram on the left, I've got 30 degrees and 60 degrees. So you can see like the peach colored triangle is our 60 degrees. So this triangle here, and how that's repeated in the 4 quadrants. So that's 60 degrees. And then for the blue, although I'm going around it in green, is your 30 degrees, and that's repeated as well. So we've already looked at these exact values. So if we just look at 60 degrees, see how they're quite similar. It just depends on whether they're negative or positive because of the quadrant they're in. All right, so the symmetry properties, the symmetry just means it's the same, okay, symmetrical. It's the values are the same, it's just whether there's positive or negative. For 45 degrees, it's a little bit easier to remember because your cos and your sine are both root 2 on 2. Just remember, you might see it as 1 on root 2. So I think there's some questions we're going to do later that's 1 on root 2 is the same as root 2 on 2. It's just rationalize the denominator. So you can see here it's negative because we're in the second quadrant, and in the second quadrant cos is negative. All right, so we're going to look at that in a little bit more detail. We'll do some questions very soon. So writing an angle in terms of its reference angle. So hopefully by now, you know, we always go from the horizontal. So you can see in these 4 quadrants, our reference angle is the red angle, and then the blue is our actual angle. So we always use the reference angle to calculate its exact value. So what I mean by exact value are these values here. You can see they're just repeated. It's just whether it's positive or negative. Okay, so the reference angle tells us our exact value, and the quadrant we're in tells us whether we're negative or positive. So you can see in the first quadrant it doesn't matter, because in your first quadrant that's where your reference angle is anyway. If you are between, and I might just stick to degrees, if your angle is between 90 or 1 to 180, which it is in this one, we go 180 minus theta. All right, so we're going that way to get our angle. If it's between 180 and 270, we go 180 plus our angle. And then if we are between 270 and 360, we go 360 minus our angle. All right, so we always go from the horizontal. Okay. That's just repeated here. Okay, so your reference angle is your given angle if you're in the first quadrant. If you're in the second quadrant, it's 180 minus your given angle. In your third quadrant, your given angle minus 180. And then 360 minus your given angle. Now we can change all those angles from degrees to radians. So remember, 180 is the same as pi. And then 360 is the same as 2 pi. All right, so let's have a look at these questions. So write down the reference angle for each of the following. So for the first bunch of questions, we've got our angles in degrees, and for the second one, we've got our angles in radians. So remember, this symbol just means radians. We don't tend to write it though. So when you're doing your reference angle, always think about which quadrant you're in. Okay, so I'm just going to rewrite the angles in degrees. Okay, so 135 is in the second quadrant. All right, so we're going to, if we go back to this, we're going to use this formula, 180 minus our given angle. So 180 minus 135 is going to give us that reference angle. Tan 180, you can do exactly the same thing, just 180 minus 180, which is going to be 0. So that would give you that reference angle there. Cos 150 also in that first quadrant. All right, so 240 degrees. We are in the third quadrant. So when we're doing the third quadrant, we're just going to do the given angle minus 180. So we're going to do 240 minus 180. 315 is in our fourth quadrant. So if I go back here, it's 360 minus the given angle. So 360 minus 315. Obviously, you'd have to do the answers for this, but I'm just going quite quickly so we can remember how to do it. 210 is in your third quadrant, so that's going to be 210 minus 180, 330, so 360 minus 330, and so on. So basically your reference angle, we tend to just work with 30, 45 or 60, because if we're doing exact values, they're the only exact values we need to know. But if you're doing a reference angle, it's just an angle in this first quadrant. So it should be an angle between 0 and 90 degrees, what you should be left with. So if you can just remember this. All right, so, and if you understand your unit circle, you don't have to learn these formulas off by heart. You should just understand how it works. All right, if we're doing radians, all right, so this is a little bit harder. So I'm going to change this to put radians on. All right, so we're going to have pi on 2 up here, pi, 3 pi on 2, and then we're back at 2 pi. All right, so it's the same thing, but we're just working in radians now, not degrees. So 2 pi on 3. Now, if you're ever unsure what that is, just think of it as a fraction without the pi in it. So if you think about it in terms of 2 over 3, and if I was, and I might write this in pink on the unit circle I've got here, if we just ignore the pi, all right, it's a little bit easier to understand where we are. All right, so 2/3 is smaller than 1. All right, so 2/3 is smaller than 1 because we haven't quite got a whole. So if you think about eating 2/3 of a pizza, you still have a third left. But is 2/3 greater than a half? Well, yeah, it is. So we're in the second quadrant. So when we're in the second quadrant, all right, if I just go back here, we're going to do pi minus the given angle. So pi minus 2 pi on 3. Now, if you can't work that out because you've got a fraction in there, and some people find it difficult to do fractions, just make it so your fractions both have the same denominator, and it's going to make it a lot easier for you. So we keep the denominator as 3. So when we're doing adding or subtracting fractions, we keep the denominator the same, and then just, in this case, subtract our numerators. So 3 pi minus 2 pi is going to be pi on 3. All right, let's do another one. So 3 pi on 4, if you think of it in terms of 3/4, all right, we haven't quite got to a whole pi yet. So we're going to be doing pi minus 3 pi on 4. Again, if you can't do that subtraction, just change it so we've got the same denominator. So 4 pi on 4 is the same as just pi. And then 4 pi minus 3 pi is just pi. 7 pi on 6. So 7 over 6, we've gone past a whole. Right? We've got 1 whole and 1/6. So we've gone past a whole. All right, so when we're going past a whole pi, we're now in the third quadrant. So it's going to be the given angle minus pi. So 7 pi on 6 minus pi. Again, you can change that pi to have the same denominator. So 7 pi minus 6 pi is pi. So just pi on 6. All right, let's have a look at h, because h is slightly harder. Oh, so is f or an e. Okay, let's do e. So 5 pi on 3. So again, if you're struggling to recall which quadrant that is in, just think of it as 5 on 3. All right, 5/3. So 5/3 is bigger than pi. Now, you've got to say, well, am I in the third quadrant or the fourth quadrant? So 5 pi on 3 is nearly at 2 pi. All right. If you think of 6 pi on 3 is the same as 2 pi. All right. So 6 divided by 3 is 2, so it's 2 pi. So you've really got to think quite carefully about which quadrant you're in. You could also say, well, how does 5 on 3, so how does this number here compare to 3 on 2? Is 5 on 3 bigger than 3 on 2? So 5 on 3, 5/3, and 3 over 2. So 3 over 2 is 1.5. 5 over 3 is 1.666666. Okay, so I know which quadrant I'm in. All right, so extremely important that you know your fractions or how to deal with fractions. All right, so we're in the fourth quadrant. So in the fourth quadrant, this is the formula we're using. So 2 pi minus 5 pi on 3. Now I don't have the same denominator, so I can make them have the same denominator. I can make that a 3. So that just means that 2 I have to multiply by 3. So that becomes a 6. So 6 pi minus 5 pi is pi, so pi on 3. Right? So when you get to doing radians, it is a little bit harder because it's not, I guess, easy to know where you are, because angles, it's easier, but just dealing with fractions. Okay, just take your time and think about which quadrant you're in. Let's just do h. So for h, I'm at 17 pi on 12. So 17 pi on 12, if I was to write that as just a fraction, 17 on 12 is the same as 1 and 5/12. So I'm not quite at 1.5. So 1.5 would be 1 and 6/12. So I'm actually in this third quadrant here. So when I'm in that third quadrant, I'm going to have the given angle minus pi. So I'm just going to write that down. So 17 pi on 12 minus pi. Now if you want them to have the same denominator, just make sure whatever you do to the top, you do to the bottom. All your reference angles, remember, have to be in this first quadrant. So they have to be between 0 and 90 degrees if you're working in degrees. Or if you're working in radians, they have to be between 0 and pi on 2. So 5 pi on 12 is between 0 and pi on 2. All right, so pi on 2, if we have the same denominator, is 6 pi on 12. All right, it might make it a little bit easier to compare. So 5 pi on 12 is not quite pi on 2, or half of pi. All right, so a little bit trickier, that one there. All right, let's move on. So converting degrees to radians, so just using this formula, it's just always going to be pi on 180. Sorry, it's going to be pi and 180 times pi and 180. It just depends whether it's going to be the reciprocal of that or not. If you choose the wrong one, you're going to end up with pi squared. So what I mean by that is if I wanted to say convert 2 pi into degrees and I accidentally did pi over 180, I'm going to be ending up with 2 pi squared over 180, and you shouldn't end up with pi squared. So you know you've done it the wrong way. All right, so I'm like, oh, oops, wasn't meant to do that. I was meant to multiply by the reciprocal of that. So 180 over pi. So our pi's cancel out. So 2 times 180 gives me 360 degrees. And remember, your degrees shouldn't be in terms of pi. All right, so you should be able to use that formula. So just pi on 180 or 180 on pi, depending on what direction you're going in. All right, so converting here, let's just do a few questions. So if we're going from 60 degrees, all right, so remember, we want pi in our answer. So if I put pi on the top, it's going to be a part of my answer. So we can just see we're going from degrees to radians. So 60 times pi, 60 pi over 180. Now we just need to simplify that. So 6 is your highest common factor, so it's going to be pi on 3. All right, and we've seen 60 is one of our reference angles, so we should know that's pi on 3. I feel like we've done quite a few of these. So again, as I said, if you did it around the wrong way, you're going to end up with an answer that just looks wrong. All right, we can't have pi squared. So you'd be like, oh, I should have done it the other way around. All right, so 180 on pi. So I'm doing question G here. So our pi's cancel out. Now we've got 5 times 180 over 3. You can simplify this first. So 180 divided by 3 is 60. So that gives you 300 degrees. All right, let's move on. I'm just conscious of how long this video is going. All right, so your exact values, we've kind of worked through the exact values, these values here. All right, and it's extremely important that you remember them. So I think, and to be honest, I've never taught it with the unit circle. I've done the table of values or I've done the triangles, but I'm starting to think it's actually quite easy to remember them here. So whenever you do any trig work, so in the future when you're doing methods, just think of this first quadrant. All right, so I've just drawn it there. So we've got our 3 lines. All right, this is your 30, this is your 45. Whoops, didn't do them. And that's your 60. All right, and if we're doing them in radians, we have pi on 6, pi on 4, pi on 3. And we have our coordinates. All right, so remember they're all over 2. And then we go root 3, root 2, 1, root 3, root 2, 1. Now, the only thing that this does not tell you, and remember that your coordinates are cos sine, all right, so reading them, you know, that's your x and that's your y, is your tan. All right, so for tan, remember, tan is equal to sine over cos. So if we had to do tan of pi on 6, the sine value is 1/2, and the cos value is root 3 on 2. I might just do it over this side. So we're doing 1/2 divided by root 3 on 2. So when you're dividing a fraction by a fraction, we do keep change flip. So we keep the first fraction, change the division to a multiply, and then flip the second fraction. So those 2's cancel out and we end up with 1 on root 3. Now you can rationalize that denominator, so you might see root 3 on 3 as well. All right, so that's how you can get your tan. Now, some people just remember the triangle, so that's why I've put this one in here. So if we were to have a look at 30 degrees, and that's 1, and this is your hypotenuse, this is your opposite, and this is your adjacent. Now, the way this this works is, I'm just trying to remember. Sorry, I might just take it away from, we can leave the 1 there, but it will work out better if we don't make it 1. So if your hypotenuse is 2, so if you can remember the numbers for this triangle, so we've got a 2 and then a, let me just figure it out for a sec because I never use the triangles. So that's going to be 1, and that must make this one √3. So if you can remember this triangle, this 1, 2, and √3, you can do both 30 degrees, and I might just change this color here, and this is your 60 degrees here because it's a right angle triangle. So if you remember these angles around the side, the 1, 2, and the √3, then you can actually work out your exact values. So if I wanted to work out sine of 30 degrees, so remember sine is equal to opposite over hypotenuse. So for this one, our opposite is 1 and our hypotenuse is 2. And you can see that's your value there, 1/2. If we were doing sine of 60 degrees, this time our opposite side would be √3 and our hypotenuse is 2. And you'll do the same for cos. So cos is equal to adjacent over hypotenuse. So our adjacent side is √3 on 2. And then if we were doing 60 degrees, then it would just be the opposite of what it was for sine. So it would give you 1/2. So however you remember your values, and some students prefer just memorizing the table, but I'm kind of thinking just learning that first quadrant there with those values is helpful, and remembering tan is equal to sine over cos. All right, let's keep going. So there's your 45 degrees. 45 is easy to remember because it's √2 on 2. Always. It might be 1 on √2 if it hasn't rationalized the denominator. So it's the same for sine and for cos. All right, so determining exact values using a reference angle. So you need to always find your reference angle to work out your exact values. So first of all, we've got 2 pi on 3. So you need to work out which quadrant you are in. So this is our second quadrant. So sine 2 pi on 3 is equal to sine pi minus 2 pi on 3. All right, so if we just go back up to what we did back here, let me just scroll. Oh, to here. All right, we're in the second quadrant. And because we're in radians, I'm not doing 180, I'm doing pi. Let me just figure out where I am. All right, so we've got sine pi on 3. Now, sine pi on 3 is equal to, what is that, √3 on 2. All right, so just remembering your exact values so you can answer questions like this. So once you can, if you can find your reference angle and you know your exact values, then you should be able to answer questions like this. Let's have a look at a tan one. So I might do question G. All right, I made a boo-boo with G, so I'm going to do it again. So just deleted that mistake from the video and starting again. So if it looks a little bit strange, you're wondering what is going on, so I just made an error and I don't want that error in the video. Okay, so looking at tan 5 pi on 6, so in your unit circle, remember you're going from either 0, pi or 2 pi. Now our denominator is 6, so if you want to, you can think of pi as 6 pi on 6. So 5 pi on 6 is going to be the same as pi minus pi on 6. So we're in this quadrant here. Now in this quadrant, tan is negative, so our answer is going to be negative. So we're going to have negative tan, and our reference angle is pi on 6. Now, to remember, so this is where you need to remember your exact values. There are multiple ways you can remember your exact values in your, you can refer to your unit circle. So here, so we're doing pi on 6, we're looking at these values here, so root 3 on 2 and a half. So that means cos is equal to root 3 on 2 and sine is equal to a half. And remember that sine, that tan, just on the side here, is equal to sine over cos. Alright, so when we're working out this value, we can change that tan to be sine pi on 6 over cos pi on 6. And sine pi on 6 is root 3 on 2, and cos pi on 6, oh, I got that around the wrong way, I think. Sorry. It's a half, and that's root 3 on 2. Alright, so when we're dividing a fraction by a fraction, we just keep the first fraction the same, change the division to a multiply, and flip. So we get those 2's cancel out, and we're left with 1 on root 3. And you could rationalize the denominator, so it's root 3 on 3. Now, another way of doing this, and I can't recall whether I cut this out of the video or not, so you could refer back to your triangles. So triangle here. All right, so we've got 30 degrees, which is the same as pi on 6. And what do we have? 2, I'm trying to remember what it was. 1 and root 3. So tan pi on 6 is, so using SOHCAHTOA, opposite over adjacent, your opposite side is 1 and your adjacent side is root 3. So you can see you get the same result using the triangles as well. So just however you remember your exact values, either using your unit circle, I was trying to think, what is it called? Or your triangles. All right, and there's your answer. And it's negative because we are in the second quadrant. All right, bye guys. The same one that we did here. Okay. All right, so that might come with a little bit more practice with the tan if you're only remembering sine and cos, but you can remember tan as well if you can. But tan is just equal to sine over cos. If you're using your triangles, let me just go back up here. So if we're using our triangles, I can also do tan of 30, and tan is equal to opposite over adjacent. So your opposite side is 1 and your adjacent is root 3. So you could do it that way as well. All right, if you remember that triangle. All right, I'm just conscious of time. So let's just have a quick look at sine and cosine graphs. So here I have a sine graph. Sine graphs always start at 0 unless you've had any transformations or translations. So if it's shifted up or down or left or right, it won't start at 0. But at Year 10, we're just going to do basic ones. All right, you'll notice all these dots actually represent these points on your graph. So if we look at these key points here, oops, that was that point up there, and then there's pi, then we're down the bottom there, and then we're at 2 pi. Then these points in between, so here we have, that's actually pi on 3, this point here. And then we've got pi on 4, which is written for you, and then we've got pi on 6. Now, if we were to do our exact values, you will notice, and if I just use this one here, all right, so I know that sine of pi on 3 is equal to 1/2, and there's 1/2 here. So if I was to go across, all right, you can see it's hitting my graph twice. It's hitting here at pi on 3, and it's hitting here again at a value that's not on my graph. All right, but this point here is just going to be pi minus pi on 3, so it's 2 pi on 3. Hold on, just making sure 3 pi on 4. I know where I went wrong. This should be pi on 6. I always got them around the wrong way. Silly, silly me. Pi on 6. So it's pi on 6. That's pi on 3. Pi on 6. So that is pi minus pi on 6, which is 5 pi on 6. Sorry, I'm rushing and making errors. Now, if we were to do the negative, so down here is -1/2, and I was to go across, you can see it's hitting at this point here, and this point here, because we're in now this the third and the fourth quadrant. So this value here would be pi plus pi on 6, and this point here would be 2 pi minus pi on 6. All right, so that's how you can solve equations using your graph. Now, half is a little bit easier to find on that axis, but if we just have a look at pi on 4, so this value here is actually root 2 on 2. So if I was to put that into my calculator, I would see that root 2 on 2 is just slightly below 0.75. All right, so I'm not going to do that on the calculator because I'm just running out of time. Your cosine graph works pretty much the same. It's the same shape, but starts at 1. So the main difference is it starts at 1, and these key points are just slightly different. And I've got this one in degrees. All right, and then we're finishing at 300 and, whoops, there's 360 up there. It hasn't got a dot, got me confused. All right, so there's 360 up there. So if we were to do 0.5 for this one, if we go across, and this is a cosine graph, you can see it hits there at 60, and if we keep going across, the other solution is here at 300. If we were doing negative 0.5, there's one solution at 120, and then 240. All right, so your period and your amplitude. So your amplitude we'll do first. Is always easy to spot. It's just the number in front of your sine or your cos. So there are our amplitudes. All right, so we'll keep them colored in yellow. Now your period, now this is only for sine and cosine graphs, is equal to 2 pi on n, where n is the number in front of x. All right, so let's highlight, actually, I'm going to get rid of that because I don't want you to get confused. I'm going to highlight n in purple. All right, so the first one's just going to be 1. It's not really there. There's a 4, a 3, a 2, a half, a third, and 2/3. So your period, so for A, your value of n is 1, so your period is 2 pi on 1, which is just 2 pi. For B, n is equal to 3, so your period is equal to 2 pi on 3. For C, n is equal to 2, so your period is equal to 2 pi on 2, which is just equal to pi. For D, we've got n equals 1/3, so your period is equal to 2 pi on 1/3, which is the same as 2 pi times 3 on 1, so 6 pi. I've put this other question in because you do also need to know translations. So we didn't cover horizontal translation, so just vertical. So it's just what's been added or subtracted. So this number that I've highlighted in green, if it's positive, it means your graph's shifted up or down. If it's positive, it's shifted up, so it's gone up 1. Here it's gone down root 3, and this one it's gone down 1. All right, solving equations. We kind of looked at that already. Okay, so I'm just trying to think of key things here. Notice how they're intersecting here. So that's 8 pi on 4. And our corresponding y values, root 2 on 2. You can see they're also intersecting here. So that's going to be at pi plus pi on 4, which is 5 pi on 4. And that's going to be negative root 2 on 2. Let's just have a look at a few of these. So I'd like you to get used to understanding how you can use the graph to solve equations, but as you move into VCE methods, you probably wouldn't so much use the graph. You would just remember your exact values. So if you know your exact values, you can work these out, and we're dealing with degrees here. So root 2, and I've got a graph in radians, but anyway, so root 2 on 2 I know is pi on 4, so theta is equal to pi on 4, and pi on 4 in degrees is 45 degrees. So that's all it's asking for this. So, and you can see that intersection here. Root 3 on 2, so if you complete your unit circle correctly, sine of root 3 on 2 is 60 degrees. So you can just read that straight off. Where are we? Okay, this one here. So 60 degrees. Sine of a half, it's just your complement, so it's going to be 30 degrees. Negative a half, so this time, if we think of the graph, we're going to be down here. So there's negative a half, and we're going to be doing the red. So you can see it's here. All right, and because it's a half, it's going to be 30 degrees. So it's 180 plus 30 degrees. So 210. And it also hits it here. So we've got this solution as well, because we're in two separate quadrants. Actually, I probably should have done the two solutions for the other ones as well. Just bear with me, we'll do them in a sec. So this one is going to be 360 minus 30, which gives you 330 degrees. All right, let's just go back to A. So we did one solution here, and then your next solution is going to be up here. So that's just going to be 360 minus 45, which gives you your 315. So if you understand your unit circle, you should be able, and your exact values, they all relate to each other, you should be able to solve the equations. I think, let's have a look at these ones here. Using the unit circle instead of the graphs is also quite beneficial. So when I do this at VCE level, I always just say use your unit circle, don't use the graph. The graph just helps us see that you've got multiple solutions. So if we're looking at root 3 on 2, first of all, we've got to think, well, it's negative. So where is cos negative? It's negative in this quadrant here, your second quadrant, and your third quadrant. So we're going to be looking for a solution there. Now, root 3 on 2 is cos of 30, I think. Gosh, I should know my exact values by now. Cos of 30, yes. So our reference angle, and are we working in degrees? Our reference angle for the first one is 30 degrees. So that 30 degrees gives us our root 3 on 2. So we want these two other solutions because it's negative. So the first one, I might just do here, the first one's going to be 180 minus 30, which gives us 150 degrees. And then the other solution is 180 plus 30, which gives us 210 degrees. If I look at my unit circle, the one that's completed, you can see we've got the negative root 3 on 2 there and negative root 3 on 2 there at 150 and 210. All right, so it all relates back to your unit circle. All right, let's just do one. So if we have a look at question D, so we've got 2 cos theta plus 1 equals 0. All you need to do for this one is just rearrange it. All right, so we're looking at where cos is negative, so I've already highlighted them. The exact value for a half, so our reference angle is 60 degrees. So before we did the 30 degrees, this time we're going to do pretty much the same thing. It's just going to be 180 minus 60 and 180 plus 60. So your two solutions are going to be 120 degrees and what's the next one? 240 degrees. So if I go back to my unit circle, so we're looking at cos negative a half. So cos is our x. All right, and you can see there at 120 and 240, which is what we got, 120 and 240. So for these other questions, when you do the radians, it's exactly the same thing. So if you need to rearrange them, so these would all need to be rearranged. All right, it's just like a algebraic equation, just take things over to the right-hand side. All right, all the best. Just under 1 hour. Okay, bye girls.